State functions are those properties which depend on the present state or situation of the system. For example, temperature and pressure of the system are state functions. These can be measured at any time and will be fixed for a given state. Path functions are properties which depend on the path taken by the process. For example, heat transfer and work done are path functions. These cannot be measured at any point, but can only be measured as a quantity which exists between two states. From the first law of thermodynamics, delta U is equal to Q minus W. For any two states 1 and 2, which have a fixed internal energy difference of U1 minus U2 between them, we can imagine an infinite number of combinations of Q and W, so that the first law remains true. For example, if delta U is 10 joules, one option is Q is equal to 20 and W is equal to 10 joules. But any other option, where Q minus W is equal to 10, such as 11 and 1, or 190, will also satisfy the first law. So in all these cases, even though the internal energy is fixed, as the states are fixed, the heat and work transfer depends on the process or path which is taken to transition between these two states. If we represent this in a graphical form, using PV diagram. For any two states, 1 and 2, there can be an infinite number of paths to transition between them. Depending on the path taken, the area under the PV curve will change. Since the area under the PV curve is the same as work done, depending on the path taken, we have different values for work done. The end states 1 and 2 are fixed, so the change in internal energy is also fixed. And so, according to first law, as work done changes, the heat transfer also changes. So, both heat and work done are dependent on the path taken by the process. Hence, heat and work are path functions.